Okay, chapter 7, practice test. Let's go through this. So first thing you've got here is the chart. Please keep in mind that do not use a calculator means we need to see all the steps. So you're using something from this chart probably if I say I want to see all of the steps. Okay, so there's more space on this chart than you actually need just in case you want to put some extra angles in there, but the ones you absolutely need to know start at 0, which is 0 degrees. And then we also have 30 degrees, 45 degrees, 60 degrees, and 90 degrees. If we know those angles, we can do everything else in this chapter. Keep in mind that 180 degrees is the same as pi. So how do we go from 180 down to 30 degrees? We divide by 6. So 30 degrees is pi divided by 6. Sorry, pi divided by 6. 45 is going to be 180 divided by 4. 60 is going to be 180 divided by 3, and 90 is 180 divided by 2. All right. If you can count to 4, you can get this chart memorized. You don't have to memorize every single thing. Just remember this, that every single box for sine is the square root of something divided by 2. The square root of something divided by 2. Square root of something divided by 2. Square root of something divided by 2. The square root of something divided by 2. All right, how does this work? 0, 1, 2, 3, 4. Okay? So if you can count from 0 to 4, you can remember what's going on here. And then keep in mind that the square root of 0 is 0. 0 divided by 2 is just 0. The square root of 1 is just 1, so this box becomes 1/2. And I tell people, if you're going to memorize one thing, memorize this one right here. The sine of 30 is 1/2. If you remember that, everything else can build off of that. Root 2 over 2, root 3 over 2 doesn't reduce, but the square root of 4 is 2. 2 divided by 2 turns into 1. Okay? So now we've got the numbers for sine. If we have cosine, that's just the reverse, because remember, the sine of an angle is equal to the cosine of 90 degrees minus that angle. Complementary angles. So the sine of 0 is the same as the cosine of 90. The cosine of 0 is the sine of 90. The cosine of 30 is the sine of 60, root 3 over 2. And flip here, 1 over 2. And in the middle will stay the same because 45 plus 45 is 90. And then we have tangent underneath it, so we can just divide straight down because we know that tangent is sine divided by cosine. So 0 divided by 1 is 0. 1 divided by 0, undefined. Root 3 divided by 1, remember if we divide, these 2's are going to cancel. We'll have the square root of 3. Root 2 over root 2 is just 1. And then here we'll have 1 over rad 3, which is rad 3 over 3. And then to do the remainder of the boxes, we're just going to do the reciprocals. Cosecant is the flip of sine. 0 flipped over is undefined. 1 flipped over is 1. 0 flipped over is undefined. Let's go to the end here. These ones are easy also. 1 flipped over is 1. 0 flipped over is undefined. And undefined flipped over is 0. Let's take the rest of these. 1/2 flipped over is 2. Root 3 over 2 becomes 2 over rad 3, which is 2 rad 3 over 3. And then rad 3 over 3 flipped over becomes rad 3. Now, cotangent is actually pretty easy because cotangent theta is a complementary angle to tangent. Tangent of 90 degrees minus theta. So the cotangent of 0 is the same as the tangent of 90. The cotangent of 90 is the tangent of 0. So rad 3 and rad 3. So this box here will be rad 3 over 3. And 1 and 1 match up. Finishing up, let's go across with our cosecant. Rad 2 over 2 flipped over is rad 2. 1/2 flipped over is going to be 2. And rad 3 flipped over is going to be 1 over rad 3, which is rad 3 over 3. Okay, so you're going to want to be able to fill that whole thing in the beginning, but remember, we're not memorizing this. We're memorizing maybe that sine 30 is 1/2, and then we're remembering its square roots of 0 to 4 all over 2, building it from there. Okay, we have some formulas here. S equals r theta. So let's just plug this in. 8 equals 1/3 of a foot times theta. So we'll times both sides by 3, and we'll get 24. The feet cancel out, but when we introduce theta, theta is always going to be in radians. Okay, that equals 24 radians. Let's convert. Converting from degrees to radians, we're going to multiply by pi over 180 degrees. Degrees cancel out, and we end up with 87 pi over 180. Okay, those are both multiples of 3. So if we divide by 3, we're going to get 90 divided by 3 is 30, so 87 divided by 3 is 29 over 60 is our answer. All right, rad 6, we're going to convert this from radians to degrees. So this is rad 6 times, we need radians in the denominator, so pi and 180 on top. And so we'll have rad 6 times 180 divided by pi gets you approximately 140.35 degrees. Okay, as part of an experiment to test different liquid fertilizers, sprinkler has to be set to cover an area of 130 square yards in the shape of a sector of a circle. So, shape of a sector of a circle. We have our pie slice, our pizza slice. The radius is 30 yards, and the area is 130. So with this, we're going to go area equals 1/2 r squared theta. And our job is to figure out through what angle the sprinkler should rotate. So we know that 130 square yards equals 1/2 30 yards squared times theta. So it's times by 2. We'll get 260. And we'll divide yards squared away, 260 over 900 equals theta. Okay, so it does say to round to 2 decimal places, so let's go ahead and grab our calculator. There it is. Okay, so 260 divided by 900. So it rotates through 0.29 radians. Theta equals 0.29 radians. Okay, indicated operations. Let's flip this over. The flip of cotangent is tangent squared minus the flip of cosine is secant squared. And we know that secant squared from our formulas, our Pythagorean formulas, is equal to tan squared plus 1. So this will be tan squared theta minus, use substitution, tan squared theta plus 1. So these will cancel out, and we're going to minus 1 to get negative 1. Let's do the same thing over here. So a couple options that we have here. One thing that we can do is just know that secant is the flip of cosine. So this is secant is hypotenuse over adjacent times sine. Sine is opposite over hypotenuse. And the whole thing divided by tangent. Tangent is opposite over adjacent. Then the whole thing plus 1. Let's clean this up. Those cancel. So we would have O over A divided by O over A, 1. Over A divided by over A is just 1. So 1 plus 1 equals 2. All right, find the remaining 5 trig functions. Let's make ourselves a triangle. Theta. And so if the cosine of theta is 5 over 13, the adjacent is 5, and the hypotenuse is 13, which makes the opposite side 12. So if we know cos, we also know secant. Secant of theta is just the reciprocal, 13 over 5. Let's do the sine. Sine theta will be 12 over 13, which makes the cosecant 13 over 12. And then the tangent of theta is 12 over 5. So the cotangent is 5 over 12. Same deal on 8. Let's make ourselves a right triangle. Theta, opposite, over adjacent, so 1 in this case, because we could put this over a 1. And let's use Pythagorean theorem. 1 plus 2 rad 6 squared will equal your hypotenuse squared. And so this is 4 times 6, which is 24. 1 plus 24, which is 25. The square root of that is 5. That's your hypotenuse. If we know the tangent, we know the cotangent is 1 over 2 rad 6. So to clean that up, we would have rad 6 over 12. And then the sine of theta is going to equal 2 rad 6 over 5. If we flip that over for cosecant, we're going to have 5 over 2 rad 6, which is equal to 5 rad 6 over 12. And then we have, what are we missing here? The cosine is going to be 1 over 5. So that makes the secant 5 over 1, or just 5. For this one, we're going to use our complementary angles. The cosine of 20, the exact same thing as saying the sine of 70 degrees. So we can replace the fraction here, cosine of 20, with sine of 70. And then we'll have sine of 70 over the cosine of 70. And remember that tangent is sine divided by cosine. So we have tangent of 70 minus tangent of 70. And so we get 0. Okay, if tangent of theta is 4, find the exact value of cotangent of 90 minus theta, pi over 2 minus theta. Tangent of theta is equal to cotangent of pi over 2 minus theta. They are complementary trig functions. So if tan theta is 4, then so is the cotangent of pi over 2 minus theta. The answer here is just 4. All right, for this one, we're going to go to our table. The tangent of pi over 6 is, that's going to be root 3 over 3. And the sine of pi over 3 is rad 3 over 2. And so now we're going to have to come up with a common denominator and just go from there. So this problem, you're just looking at your table. Times by 2, times by 2, times by 3, times by 3. So we have 2 rad 3 minus 3 rad 3 all over 6. So we have negative rad 3 over 6. Okay, again, looking at our table, this is 3 times the cotangent of 45 is 1, plus 8 times the sine of 30. The sine of 30 is a half squared. So 1 squared is 1 times 3 is 3. A half squared is a quarter. A quarter of 8 is 2. So our answer here is 5, just from the table. Again, on the table, this is rad 3 over 2 squared minus rad 2 over 2 squared minus 1/2 squared. So we'd have 3/4 minus 2/4 minus 1/4. Notice how the minus is not being squared, so it's still a minus. And so we're going to get a big old 0. Okay, so we're looking at our calculator for these. So grab a calculator, cosecant of 50 degrees. First things first, let's make sure we're in degrees. So mode. Right now we're in radians here, so let's go change that. And we'll go back to our main screen. We're looking for the cosecant of 50. Cosecant is 1 divided by the sine of 50. Answer is 1.31. Alternatively, we could have done sine of 50. Got an answer, and then hit the x to the -1 button. Get the same thing. We are not going to do sine -1, cos -1, or tan -1. That's the inverse sine, cos, and tangent, which we have not learned about yet. You'll learn about that next year. Cotangent of pi over 5. So we are in radians now. Let's go to mode. And cotangent is 1 divided by the tangent of pi divided by 5. 1.38. Okay, tree casts a shadow of 26 meters. Let's build a tree. Okay, we've got our sun. And that casts a shadow of 26 meters with an angle of elevation of 24 degrees. And we want to find the height of the tree. So we're going to say the tangent, 24 degrees, is equal to height divided by 26 And we're going to multiply 26 times tangent of 24 to get the height of that tree. In our calculator, I believe we're in radians again, so go back to degrees. Second quit. And what do we have here? 26 times tan 24. And we have a tree, 11.576, and it's said to the nearest meter, so we'll say 12 meters, the height of the tree. So hikers on opposite side of the canyon, so we got a canyon here, we got a canyon here, and we look down at an angle of depression. Angle of depression is going to be here, 37 degrees. And this one will look like this, looking straight out and then rotating down 21 degrees here. And the height for both of these is going to be 525. Our job is to figure out how far it is from here to here. So we'll call that x1. And then how far is it from here to here? We'll call that x2. So the tangent of 37 is the opposite over the adjacent, and the tangent of 21, the opposite side, 525, over the adjacent. And so we can move these around. X1 is equal to 525 divided by tan 37. And X2 is equal to 525 divided by tan 21. Let's plug these in. 525 divided by tan of 37. 696.7, and 525 divided by tan 21. 1367.7. And we're going to add these together. Use the actual values. So press up, hit enter, and we'll say plus. Go up and press enter. And we'll get our actual values, and it is 264.37. 2064. 37 says round to the nearest 12 meter. There you go. The angle 23 pi over 6, find a coterminal angle that lies between 0 and 2 pi, negative 2 pi and 0, and negative 720 and 360. I'm going to rewrite 0 and 2 pi as 0 and 12 pi over 6, because the denominator we're working here is 6, and this would be negative 12 pi over 6 and 0. So 23 pi over 6 is too big, so we can always subtract a whole circle. Let's subtract a whole circle. 2 pi, which is 12 pi over 6. Gets us down to 11 pi over 6. Is that between 0 and 12 pi over 6? It is. That's our first answer. Let's do it again. We get a negative version. Negative 1 pi over 6. That's in between these two. And let's go do it again. Negative pi over 6 minus another 12 pi over 6. Sets to negative 13 pi over 6. But we do want this one in degrees as indicated here. So we'll times it by 180 over pi. Pi's cancel out. And so 180 over 6 is 30. And 30 times 13 is 390. Negative 390 degrees. Okay, use a coterminal angle to find the exact value of the expression. So 750. 750 is not something that's on our table, but if we took away 2 full circles, we'll end up with 30 degrees. So we're finding the secant of 30 degrees. Secant is the flip of cosine. The cosine of 30 degrees is equal to rad 3 over 2. So the secant of 30, and this is on our table, should be 2 rad 3 over 3. The only question now is it positive or negative? So 750 is 2 full circles, 2, and then another 30 degrees. So we are in quadrant 1. In quadrant 1, all trig functions are positive. So we're going to have a positive 2 rad 3 over 3. Negative 690, how about we add 2 full circles on this one? Negative 690 plus 720 is equal to 30 degrees as well. What's the sign of 30? The answer is 1/2. The question is it positive or negative? Negative 690, that means negative 360, right? And then what do we have still to go? On this one, we have another 330 to go, which ends up right there, okay? So we are using a reference angle again in the first quadrant, so positive 1/2. Okay, 2, negative 3 is to the right but down. Your triangle would look like this with an x of 2 and a y of negative 3. So let's find everything. The sine theta equals negative 3 over 4 plus 9 is the square root of 13. So our answer is negative 3 rad 13 over 13. The secant is going to be negative rad 13 over 3. The cosine is 2 rad 13 over 13. Where the secant is going to be rad 13 over 2. Positive, because we have a positive 2. And then the tangent is going to be negative 3 over 2, whereas the cotangent will be negative 2 over 3. Same deal here for 22. Negative x positive y is in quadrant 2. We have a negative 1/3. We have a positive 1/5. And let's do Pythagorean. A third squared. Don't care about the negative because it'll be squared, plus a fifth squared. And we've got a 9th plus a 25th. So let's get a common denominator. 9 over 9. So what do we have here? 8 sets of 25 is 200. So 225 is our denominator. And we'd have 25 plus 9, so 34. Square root of that is rad 34 over 15. So our sine, right over here, so there's a little space, sine theta is going to be 1/5 divided by or multiply by the reciprocal of 15 over rad 34. So that's 3 over, when we cancel those out, rad 34. So sine theta is equal to 3 rad 34 over 34. And the cosecant theta is equal to rad 34 over 3. Right? Flip of this. The cosine theta is equal to negative 1/3 times the reciprocal, 15 over rad 34. So this is going to be 5 over rad 34. And so cosine theta is equal to negative 5 rad 34 over 34. Whereas the secant is rad 34 over 5. There's a negative there. Okay. And then the tangent is going to be 1/5 times negative 3 over 1. So the tan theta will be negative 3 over 5. So the cotangent of theta will be negative 5 over 3. Don't be scared of fractions. You can do it. Okay. All students take calculus. If sine is positive, it's one of those. If cosine is negative, it's one of those. So what's the overlap? Right here, we are in quadrant 2. Secant, which is the flip of cosine, is negative. All students take calculus. Cosine is negative in these two quadrants. Tangent is also negative. Tangent is negative in these two quadrants. So our answer is also quadrant 2. Find the reference angle of 404 degrees, 360. 360 taken away from 404 is 44 degrees, which is still in the first quadrant. Our reference angle is 44 degrees. That's what the angle in here would be. Negative 42 pi over 8. Let's go ahead and add full circles. Negative 42 pi over 8 plus 16 pi over 8 plus another 16 pi over 8. That's 32. Add another 16 pi over 8. That's 48. So negative 42 plus 48 is 6 pi over 8, which is 3 pi over 4. 1 pi, 2 pi, 3 pi. Our reference angle is pi over 4. Okay, use the reference angle to find the exact value of the expression, 4 pi over 3. Okay. So 4 pi over 3, we're going to go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So our reference angle in here is pi over 3. What is the sine of pi over 3? The sine of pi over 3 is rad 3 over 2. So the cosecant of pi over 3 is 2 rad 3 over 3. And this is in quadrant 3. All students take calculus. Only tangent is positive down there, so cosecant must be negative 2 rad 3 over negative 5 pi over 6. Let's go ahead and add a full circle on this one. We can just go in the negative direction. So negative 5 pi over 6. The half circle would be 6 pi over 6. So there's 5 of them. We'd be left over with 1 pi over 6 in here. And what is the tangent of 30 degrees? Tangent of 30 degrees is rad 3 over 3. And so the cotangent, pi over 6, would be the flip of that, which is just rad 3. And in this quadrant, all students take, tangent is positive, positive rad 3. 29, cosine is 2 over 3. Cosine is positive, but tangent is negative. All students take calculus. Cosine is positive. Cosine is positive in these two quadrants, but tangent is negative in this quadrant. So we're in quadrant 4. The cosine is adjacent over hypotenuse. 9 minus 4 is rad 5, and we're going down, so that would be a negative. Our job is to figure out what sine is here. Okay, and so we are doing sine would be negative rad 5 over 3. This says we're in quadrant 4. This is 270 degrees. This is 360 degrees. So in quadrant 4, draw a triangle. Cosine is 24 over 25, which means that Pythagorean, that's a Pythagorean triple, 7, 24, 25. And what do we need to figure out in here? It got cut off. I'm not sure what we would have to do. But if we were doing sine, it would be negative 7 over 25. If we were doing tangent, it would be negative 7 over 24. We can go from there. All right, Salt Lake City is due north of Flagstaff. Those are cities on the earth. So there's Salt Lake City, and there's Flagstaff. Okay, and the distance between them is a degree, 40, 45, and 35, 16. Okay. And the radius of the Earth is 3960 miles. Run to the nearest whole mile. The distance between them, we're trying to solve the S. All right, so remember the S equals r theta. We have the r. The theta would be the difference between the angles. So 40, 45 minus 35, 16. And we come up with 5 degrees. And what do we have here? 35, 29 minutes. Figure out what 29 minutes is. It would be 29 divided by 60. So that's 0.48. So we have 5.48 degrees. And of course, we need this to be in radians. So we're going to times this by pi. And divide by 180. And so we have 0.008 radians. And so we're going to times that by 3960, r theta. All right, so take this answer, times it by 3960. Again, using exact values, just round for the final one. So they are 33.41 miles apart. So round to the nearest mile, 33 miles apart. S equals 33 miles. All right, a carousel has a radius of 17 feet. Let's try a carousel. The radius is 17 feet, and it takes 33 seconds, t equals 33 seconds, to make one complete revolution. So our theta is a full revolution. It's 2 pi. What's the linear speed at its outer edge? All right, so our linear speed, v, formula, we could say s over t. We can say r theta over t, or we could say r omega. And the one that we're going to want to use here is this middle one, r theta over t, because we have an r, we have a theta, and we have a t. So let's plug this in. V equals 17 feet times r theta, 2 pi radians, over 33 seconds. 17 times 2 times pi. Divided by 33. So we get 3.24. What are we rounding to? 2 decimal places. 3.24. Make sure you have your units. This is feet per second. Okay, what's the displacement given by this? So on this one, we're going to make a table. We have t, and we have d equals 1 plus 2 sine of times t degrees. T is 0, 2, 4, 6, 8, 10, and 12. All right, so this is going to be 1 plus 2 times the sine of 15 times 0 is 0 degrees. The sine of 0 degrees is right there. What's the y value there? 1, 0. So the sine, the y value is 0. So 1 plus 2 times 0 is 1. 1 plus 2 times the sine of 15 times 2 is 30. 30 degrees, the sine of 30 degrees is 1/2. 2 times 1/2 is 1, and 1 plus 1 is 2. 1 plus 2 times the sine of 15 times 4 is 60 degrees. 1 plus 2 times the sine of 60 is rad 3 over 2. The 2's will cancel out, and we'll get 1 plus rad 3. 1 plus 2 times the sine of 90 degrees. The sine of 90 degrees is 1. 1 plus 2 is 3. 1 plus 2 times the sine of 120 degrees. All right, here we go. We're going to get some reference angles. 120 is the same as sine of 60. So we already did that one. The answer is right there. It's 1 plus rad 3. 10 times 1 plus 2 times the sine of 150. 150 degrees would leave us with a reference angle of 30. So the answer is going to be the same as doing 1 plus 2 times sine 30, which is 2. And then 12 is 1 plus 2 times the sine of 180. 180 degrees is right here. And what is your y value there? 0. So this is going to be 1 plus 0, which is just 1. All right, there you go. That's your entire practice test. Hope that helps. Study, study, study. Do the practice problems. Do the review test in the textbook. Email me questions over the weekend, or I'll see you on Monday after school if you are E or G block.